Okay, so welcome back to another tutorial. This is tutorial 8 on while loops. Okay, so here we have my header. All right, and then I start my main code like I normally do. Okay, and we're going to go through a couple of examples and then do projectile motion with a while loop. Okay, so if you remember last time, we did for loops. So for loops and while loops are both repetition structures. They keep doing the loop multiple times. However, a for loop has a set number of times you're going to do it. A while loop, you can set a criteria for to break out of the loop. Okay. So let's do an example here. Okay. To make sure you understand how they're structured. So we're going to define k is equal to 1. And then we're going to say while k is less than 5. Then we're going to say k equals k plus 1 and then end. So very similar to for loops, you need we're going to put while and then an end. And then here is my criteria that I'm going to break out of this loop. And then this is my equations that are in the loop that's going to keep doing it. So here what we wanted to do is we want to keep doing the loop, okay, while k is less than 5. Once it hits more than that, it should break, okay? And what happens is this. Let me run it. It starts the code and it calculates it 2. Then it goes to the end, it kind of redoes the code again, and it goes to 3. And then it goes to 4, okay? And you would think it would break out of the loop. However, it has to do it one more time. And once it says it's 5, once k is 5, it checks. If k is less than 5, it keeps going. But if it's greater, or in this case equal to, okay, it breaks out of the loop. Okay, so the while loop, the way that works in these cases is it will do one more than you think because it needs to check that last value to this criteria that you've created. Okay, so this is less than 5. So once it hits 5, that's not less than 5 anymore, and it breaks out of the loop. Okay, so this is like a criteria. These are your equations in the loop. It's going to keep doing this until it satisfies this. Okay, and it actually has to check one time more. Let's do another example. We're going to set k equal to 1 again. I'm going to pre-establish a matrix with an initial value of 5. I'm going to say while a of k is less than 1,000. Here's my equations. I'm going to keep adding 1 to my k because that's my loop indicator. And then here's a of k, which is 5 raised to the k, and then end. So if you notice with the while loop, you typically have to kind of establish a loop indicator. Make it 1 first, and then keep adding 1 to it every time. So then you know how many times you're doing that loop, okay? That's the difference between the for loops. For loops you already know, while loops you don't know, so you have to count it. Okay, here is my equation. So I'm going to build a matrix. All right, semicolon on here. And we're going to keep doing this, okay, until it's less than 1,000. So let's run this, okay? And I'm going to take this out. I'm going to type pause so you can see what happens. So it's first 5, okay. K now is 2, so it raises it to the second power, so we get 25. And then when I hit enter again, okay, it basically builds this third matrix, okay, because a of 1 is 5, a of 2, let me put that, I'll put that on here later, a of 2 is 25, a now of 3 is 125, a of 4 is 625, and then a of 5 is 3,125. So it does that value because this value now is over 1,000, but it checks it to your criteria Okay. And this is bigger than 1,000, so it breaks out of the loop. Okay, because we're going to do this while it's less than. Okay, but remember, it always has to check one more time. Okay. So again, a of 1 is 5, a of 2 is 25, and then so forth, and then keep going. A of 5, okay, this is just for reference, is the 3, 1, 2, 5. Because this criteria says keep doing the loop while it's less than 1,000, while this number is less than 1,000. But once it goes over 1,000 one time, it knows and it breaks out of the loop. Okay, so it checks it one more time. And I'm just going to do CLC. Okay, let's do another example. Let's get rid of pause. Let's do CLC, clear all, X input. Enter a positive value of X. Semicolon, while X is less than or equal to 0. CLC, F, parent F. X is not positive. /n, and then X equals input, and I'll copy this. And let me get you up here in the center here, okay? What I'm doing is I'm asking the user, like we did before in a tutorial, to give me a positive value. However, what it's going to do is if this is not a positive, it's going to come in here and it's going to tell the user it's not positive, and it's going to ask them to do another one. So let's go ahead and run it. And I'm just going to put 4. That's positive. It doesn't execute any of this while loop. But go ahead and run the code again, and we say -2. It goes in here, and it says X is not positive. Enter a positive value. Okay, I'll try a -9. Oh, it doesn't work. -3 still doesn't work. How about 2? Boom, now it works. Okay, so this is a way, sometimes while loops are used to make sure the numbers that you're using are correct. Okay. All right. Cool. So before we get into the projectile motion, hopefully just a quick summary on while loops. Again, a repetition structure. You have to have your loop indicator first in your code or in the while loop. Add one to that loop indicator. And these can be lowercase n or b, sure. These would all be B, okay? They could be anything you want. It could be poop, it could be snow, it could be window, it don't matter, okay? We have to have those. And basically, it keeps doing the loop until you break a criteria. But what happens is it actually does it one more time because it then will realize that you're breaking out of that loop, okay? All right, so let's do CLC, clear all, close all. And let's make the main example, okay? So I'm going to copy and paste some givens. We're going to do projectile motion, very similar to what we did before for the for loop. Define our constant, acceleration due to gravity. Okay. We're going to throw the tennis ball at 30 degrees. Our initial time is 0. We're going to time step, and we're going to watch this ball as it moves through the air every 0.1 second. Initial velocity is 35 meters per second. Initial position in the X and Y are 0. Here's my loop indicator for the while loop. It starts at 1. And I'm going to use this criteria, okay? And we're going to say done is equal to 0, okay? It's going to keep doing the while loop unless we make an if statement to change this value to something else. And I put 1, and it will break out of the loop. It's kind of a cool way to do this, okay? I like to use this method, but you don't have to. You can go ahead and put the criteria right next to the while loop like I did above here, okay? Here I just plotted figures, figure 1, and then here's the axis limits. Okay. So in this case where I have done, I'm going to say while not done. Okay. Basically what's going to happen, the way to think about this, it's going to keep doing whatever I have in here, equations, until done changes. Okay. So done is 0. It's going to keep doing it until I change this value to 1, 2, whatever I want. Okay. Now, if you remember last time we had X and Y equations. Okay, so because we're only doing one theta, we're going to build one row with a bunch of columns. Okay, one row. And that's why I'm just building this right here. I'm only putting one value here. I'm not like the for loop. I had I and j because I wanted multiple thetas. Here I'm only going to do one theta. Okay, and that's all we need to put there. Initial, these are just equations. V naught is a constant. T has a parenthesis j because it's going to change. Okay, we want to make sure we grab the right t value. Okay, when j is 1, we grab t of 1. That calculates x of 1. Okay, and then cosine d theta, remember, built-in function, theta is in degrees. Same thing for y. Y naught plus v naught times t of j. I think I'm missing a space to be consistent here. Times sine d of theta plus 0.5 times ay times t of j squared. Okay. So anywhere you have a matrix that's changing, you need to have parenthesis j. Okay. So x and y are changing. We're building those matrices. T is a matrix, so that has to have parenthesis j. Okay. All right. Here's the criteria to stop the loop, and we're going to use an if statement. If y of I, sorry, we're using j, right? J is less than 0, done equals 1, end. Okay. This is the criteria where I only want to plot the positive values pretty much, okay, of a ball throwing in the air. But if you remember, while loops will always go one more because it needs to check. That's their comparison. Okay. Now, T is basically going to be, whoops, let me make these into one. Plus delta T. So all of this is calculating when J is equal to 1, okay, or 2 or 3, whatever, okay. However, I want to create a new time, which is the second time matrix, by taking the previous time, which is T of 1, and adding our delta T, okay. So T of 1 is 0, but T of 2 is 0.1. T of 3 is 0.3. Okay, you see how we're going to do that, and I'll show you how this builds. And then I'm going to copy and paste the figure because we're going to plot inside, and I'll get rid of this, okay, inside the loop. Now, if you remember, hit Control, highlight them, hit Control I, and it'll format for you. I need to then, and I'll talk about this, basically update my J and then end. Okay, this is my loop indicator. So here I'm plotting a figure. Okay. I'm plotting points now because you basically I'm plotting 1 point at a time. That's what this parenthesis J means. And I'm plotting it inside the loop at the same time I'm calculating stuff. And you'll see this. I'm doing plus signs, and I'm using a marker size of 20. I'm keeping my axis limits like I had above. I'm holding on because I want to see each one of these plots made, and I'll take this off to show you. And draw now kind of keeps the graph updated, okay? Then I need to keep increasing my loop indicator because I want to build the X in the Y matrix and the time matrix, okay? If you don't put this on here, it's always going to do X of 1, or Y of 1. It's never going to change, okay? But you have to change it because you're building a matrix, okay? So this is just for me. So if J equals 2, return an end. This is just for me to show you, okay? So let's go ahead and take these semicolons off. I'll put that there, delete that, and delete this. Oh, and we need to fix that. So first thing is I don't want to have that in there anymore. So if I highlight it all, hit Control R in a Windows machine, it will comment that. Now, go back to the code here. I created the graph initially up here, and it spit out X and Y and a time and J. Say, okay, so line 70 and 71 are when J is equal to 1. You get 0 and 0. And line 79 is our T matrix. T of 1, okay, when I say T of 1, it's this. That equals 0. T of 2 is 0.1. Okay. Then line 87, J now is 2. We need that because it's going to go back up to the top of the code, and now it's going to build X of 2 and Y of 2 using T of 2. Okay. But I need to change this to show you. Okay. So way up to the top, okay, we saw this. Now, because J is 2, it built X of 2, which is 3.03, Y of 2, and on line 79, it now made our T of 3, which is 0.2. And J now from line 87 is 3. Goes back up to the top, and it does the same thing. We're going to find X of 3, Y of 3, using T of 3. Okay, so if I fix this, change this to 4, run it again, and you will see that you now have 3 values that you're building in X, 3 values you're building in Y. T now is 4, and J is 4, and it goes back up. It's going to keep doing this, keep going and going until Y is basically first one time negative, and it breaks out of the loop. Done is equal to 1. So done is still 0. Okay. Now I'm going to return, put these semicolons on here because I think you understand now how this works. Get rid of this and run it. And watch the graph. I'll talk about the graph here. Okay. And it should stop. Okay. I see these 2 arrows here. So what happened, if you noticed, we got a data point at every 0.1 second. So 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, all the way down to, I don't even know, what's the T? About 3.7, okay? So it made that plot. Now, if I don't put on hold on, it'll plot 1 point at a time. It'll be like the ball is actually shooting up in the air, okay? Because it doesn't show us the actual thing. If I take this off, it'll actually move the axes as it goes. But I like to put that whole thing back on. Okay, you would have to change this if your theta got, like say your theta is 75, and you ran it, it goes out of your axis limits, okay? And then it should come back in. So you would have to mess with these. But for the case I got here, 30 is pretty good. And we have a nice plot now. Okay. Pretty cool, pretty snazzy how this works. Okay. Here, a couple things I did different. Okay. for plotting. I plotted during the loop, which I haven't shown you before, and these are plotting points because I have parenthesis J and I made it a marker size, okay? Just to give you more practice, okay? Now, done is 1. Why? Because the last value in Y is negative. Because remember, that's how while loops work. It does it one more time, and that because it sees that it's negative, it snaps because done is 1 and it breaks out of the loop. Okay. Now you could just get rid of this and replace it with this right up there and get rid of this section here. Okay. Same thing. It's very similar to what we did up here with these criterias. Okay. I just like to do this because I like to put if statements. It helps me identify where I'm breaking the loop, okay? But you don't have to. Okay, so technically, if we looked at this, you see how I'm going to blow this up so it's easier to see. And let's go this way. And let's do this. Okay. So technically, it actually is below ground at that time, which is equivalent to this. So really, this time in the air is technically 3.6. Okay, so you have to sometimes keep an eye on that. Okay, because this is the one value that it's checking, and it actually went one more because these are the same sizes. Okay, this is 38, 3.7, and the same size actually ends right here. Okay. All right. So you really have to check. And actually, I think I was wrong. Let's see here. So technically, this would be T of 36 then. So it should be 3.5. Okay. So that's why you always check these values here. Okay. That's fine. I always forget to check that. Okay. Because it's the way that we wrote the code. All right. Y, when we calculate Y, it's just parenthesis of J. But when we're calculating T, it's J plus 1. Okay. So it's always going to be one more than our Y. So you really have to subtract 2. Okay. So technically, T flight, if you want to call it, is T of end minus 2, right? Because we should do this one, which is 36, and this is 38. So you'd have to subtract 2. Okay. So watch when I run this, it should give us 3.5. 3.5. Okay. And we can put labels on here. We'll do it after the graph. Okay. Y, X, and position of ball. Okay. Time of flight. So just be aware of how that while loop works. Okay. And make sure you pick out the right time. Okay. Because remember, it goes one more and checks. Few things I don't like here. That should have a space. And this should be position. We should say X versus Y of the tennis ball. Okay. And we should use fprintf down here to spit that value out, but that's fine. Okay. All right. Cool. So in summary, I've showed you a different ways of doing while loops. I gave you hopefully a fundamental understanding of how the while loop works. Programming can be tricky, can be tricky, but it is doable. Again, while loops are used to break out of a loop, but you don't know how many times you're doing the loop. So that's why you have to create a loop indicator, where a for loop, you already know how many times to do it. Okay. In this case, for the projectile motion, I only wanted to plot the positive because anything below that, right, it's going to be below ground. Okay. All right. Well, thank you. I hope you enjoyed, and I will see you on the next one. Bye now.